Picture this. It's 2026. You have a single Raspberry Pi 5 sitting on your desk. It's running Ollama, and it is actively answering incredibly complex questions from a local large language model. And here's the kicker. It is doing this without sending a single byte of your personal data out to OpenAI or the cloud. Nothing. It's all local. Meanwhile, that exact same $80 board is simultaneously running Home Assistant, controlling over 2,000 smart devices, and hosting your personal cloud storage. All of that running at the exact same time and drawing under 10 watts of power. Now, flip to the complete opposite end of the spectrum. Picture a tiny $15 board, the Pi 02W, sitting completely out of sight in your utility closet. It's drawing a microscopic half watt of power. Half a watt! And yet, it is silently blocking every single ad and tracking domain for every single device on your home network. It's absolutely wild. Okay, let's dive into this. In this explainer, we're going to cover every current Pi model on the market, break down their exact use cases, and give you 5 network-changing projects that you can build right now.
What we're really looking at today are the absolute extremes of the 2026 Raspberry Pi ecosystem. It's truly incredible just how versatile this hardware has become over the years. I mean, whether you need a massive AI brain crunching tokens or an invisible, ultra-low power ad blocker that you plug in and literally never think about again, there is a specific piece of silicone designed exactly for your deployment. Welcome to the explainer. Now listen, if you've been working with Linux for a bit, if you know your way around an SSH terminal, and you understand how package managers work, you are in exactly the right place. We're going to skip all the basic handholding, we won't waste your time explaining what an IP address is, and we're going to go straight to the hardware decisions that actually matter for your next build.
Let's take a quick look at our roadmap. 1. The 2026 Pi landscape. 2. The Pi 5 flagship. 3. Compact and microcontroller options. 4. Choosing the right model. And 5. 5 projects to build.
Section 1. The 2026 Pi landscape.
Okay, so the absolute crucial starting point here is understanding the true definition of a single-board computer, or SBC. A Raspberry Pi, and I'm talking specifically about the numbered models in the 0 series here, is not a microcontroller, it's not an Arduino, and it's not an ESP32. It is a full, complete computer packed onto a single printed circuit board the size of a credit card. You're flashing a complete, real-deal operating system to it, typically the Debian-based Raspberry Pi OS or Ubuntu. That means it handles multi-threading natively, it runs cron jobs, it orchestrates Docker containers, it manages memory exactly like your big, bulky desktop PC does. Plus, you get USB ports, HDMI out, gigabit Ethernet, and those iconic general-purpose input-output pins. Keeping this distinction in mind is absolutely vital as we move forward into planning out our actual projects.
Section 2. The Pi 5 flagship.
All right, let's talk about the absolute heavyweight of the 2026 lineup. This is the board that completely rewrote our expectations for what a credit card-sized computer could actually pull off. The most crucial thing to understand here is the raw, unadulterated compute power. The Pi 5 is rocking a Broadcom BCM2712 quad-core ARM Cortex-A76 processor, clocked at a blazing 2.4 GHz. When you put that into real-world workloads, it translates to a massive 2 to 3 times performance leap over the older Pi 4. It comes in 4 GB, 8 GB, and as of the 2025 updates, even an insane 16 GB RAM configuration. You've also got a built-in real-time clock, so say goodbye to needing an internet connection just to know what time it is via NTP, and dual MIPI camera interfaces for some really advanced computer vision setups. But listen up, because here's the catch. With all this staggering speed comes a very strict requirement. This board draws significantly more power under heavy load than older models. You literally have to use the official 27-watt USB-C power supply. And active cooling, like the official clip-on radiator and fan, that is now absolutely non-negotiable. If you try to run this thing hot without a fan, thermal throttling will immediately kick in and handicap that beautiful new CPU. You have to cool it.
Now here is why the Pi 5 is such a massive milestone for intermediate builders. For years and years, the biggest, most frustrating bottleneck on any Raspberry Pi was the microSD card. We've all been there, right? SD cards simply cannot handle the random read and write operations of a heavy database or a really busy server. They get sluggish, and eventually the drive just corrupts. But the Pi 5 changes literally everything by introducing a native PCIe Gen 2 lane. By throwing on the official M.2 HAT+, you can directly mount an NVMe SSD right to the board. Think about this jump. We are going from maybe 25 to 40 megabytes per second on a really good SD card up to blazing fast 400 to 900 megabytes per second of sequential read and write speeds. It completely 100% eliminates the storage bottleneck that held the Pi back for a decade.
Section 3. Compact and microcontroller options.
Now, let's be real. You don't always need blazing fast PCIe speeds or a 2.4 GHz processor to get the job done. In fact, for a lot of basic network deployments, the Pi 5 is just massive overkill, and honestly, it draws too much power. Often, you really just need 3 watts. That happens to be the idle power draw of the tried-and-true Raspberry Pi 4. Even with the Pi 5 dominating all the tech headlines lately, the Pi 4, specifically the 4GB model sitting comfortably around the $55 mark, remains the absolute best overall value out there for general-purpose computing. Its firmware was recently boosted to push its Cortex-A72 processor up to 1.8 GHz, you get gigabit Ethernet, and you get dual USB 3.0 ports. Because its annual power consumption is almost negligible, it remains the absolute gold standard if you want a 24/7 home server that doesn't need the extreme CPU headroom of the Pi 5. But wait, let's go even lower. 0.5 watts. That is the operating power draw of the Raspberry Pi Zero 2W when it's just ticking away on a lightweight network task. For $15, you're getting a quad-core Cortex-A53 processor and 512 megabytes of RAM all packed onto a board that is literally half the size of a standard credit card. It's got Wi-Fi 4 built right in. Now, sure, you do have to deal with non-standard micro USB and mini HDMI ports, which means you'll need some adapters, but its efficiency is completely unmatched. If you are building a headless node that needs to stay alive 24/7 and you want it to have practically zero impact on your monthly electricity bill, the Zero 2W with its microscopic half-watt power draw is absolutely your go-to board.
Okay, real quick, we need to do some rapid-fire disambiguation here, because this specific naming convention trips up a lot of builders. You are going to see the Raspberry Pi Pico 2W out there on the market for about $7. Now, listen carefully. The Pico is a completely different class of device. It uses the RP3050 chip, and it is a bare metal microcontroller. It is not a Linux single-board computer. There is no operating system here. None. It runs MicroPython or C directly on bare metal. So why does that distinction matter so much? Well, the Linux kernel uses a task scheduler, which means it cannot guarantee microsecond perfect timing when you're trying to control hardware. The Pico, because it's running on bare metal, gives you perfectly deterministic timing for reading delicate sensors or driving motors. Basically, you use the Zero 2W when you need a lightweight server, use the Pico 2W when you need direct, real-time hardware control.
Section 4. Choosing the right model.
All right, so we've covered the flagships, the heavyweights, the workhorses, and the tiny microcontrollers. Let's work through a really efficient decision matrix so you can match the exact right hardware to your impending project without overspending, or worse, underspeccing your build. If you just want to set up a Pi-hole or a Tailscale VPN exit node, the $15 Zero 2W is cheap, it's highly capable, and it runs endlessly on almost no power. Boom, done. If you're building a highly reliable home server, something like a Home Assistant hub, the $55 Pi 4 with 4 gigs of RAM is your sweet spot. It offers an incredibly mature software ecosystem and the absolute perfect balance of computing power and energy efficiency. Now, if you are building an NVMe NAS or doing some heavy local AI workloads, you need to step up to the $80 Pi 5 with 8 gigabytes of RAM. No question. And if you're just wiring up some simple sensor nodes for your garden, grab that $7 Pico 2W. Oh, and one very explicit note here. If you're looking at older models like the Pi 1, 2, or 3, look, they are still supported by the latest Bookworm OS, but they are completely outclassed by the modern lineup. Get this, the $15 Zero 2W actually outperforms the old Pi 3B on most tasks, while drawing significantly less power. Because of that, the older models simply aren't worth buying brand new in 2026.
Section 5. 5 projects to build.
You know the hardware landscape intimately now. Let's enthusiastically pivot over to the application phase. We're going to walk through 5 specific projects that leverage this exact hardware to completely transform how your home network operates. Project 1 is the legendary network-wide ad blocker, Pi-hole. This is hands down the absolute best use case for the Pi Zero 2W. Pi-hole acts as what's called a DNS syncal. Let's say a device on your network, your smartphone, a smart TV, maybe your kid's game console, requests the IP address of a known ad or tracking server. The Pi-hole intercepts that DNS request, recognizes it as junk based on a block list, and simply returns a null address. The result? The ad literally never loads. And because this is all operating at the network level, you do not need to install clunky browser plugins on every single device. It seamlessly kills ads simultaneously across your entire home. It only takes about 30 minutes to set up from scratch, and that tiny 02W will happily process thousands of DNS requests for hundreds of devices while drawing that microscopic half-watt of power. It's brilliant.
Next up is Project 2, freeing your smart home from the cloud by building a local home assistant hub. If you are sick and tired of your smart lights failing just because your internet provider had an outage, or if you're annoyed at paying monthly subscription fees to home automation companies just to turn on your own appliances, this is the project for you. Running best on a proven Pi 4 with 2 gigs of RAM or more, Home Assistant is a fully local open-source platform. By simply plugging in a cheap Zigbee or Z-Wave USB dongle, your Pi can talk directly to your smart devices. That means your data never ever leaves your home. No cloud dependency. You can integrate over 3,000 different devices and create hyper-specific automations. Think about gradually dimming your living room lights over exactly 30 minutes at sunset. It's all processed locally, instantly on your own silicon.
Project 3 builds right on top of that local smart home concept. We're talking about the IoT Gateway. This is exactly where we bring those tiny Pi Pico 2W microcontrollers back into the picture. You can easily deploy cheap, battery-powered Picos as little sensor nodes all over your house or yard. Have them read temperature, humidity, or detect motion, and then broadcast that raw data over your Wi-Fi using a super lightweight protocol called MQTT. You then run a Mosquito MQTT broker on your Pi 4 to catch all that incoming data, and you can use a tool like Node-RED to create highly visual, drag-and-drop automation flows. Basically, the Raspberry Pi becomes the central nervous system of your house, intelligently routing data from a whole army of bare metal microcontrollers.
Project 4 is where we really unleash the flagship. We are building a high-speed network-attached storage, or NAS, using Open Media Vault. This project perfectly illustrates exactly why the Pi 5's new PCI architecture absolutely dominates. See, if you try to build a budget NAS on an older Pi 4 using standard USB 3.0 external drives, you're going to cap out at around 25 to 40 megabytes per second. It's totally fine for some basic overnight backups, but if you attach an M.2 HAT Plus and a solid NVMe SSD to the Pi 5, you are instantly unlocking sequential read and write speeds of 400 to 900 megabytes per second. It's night and day. You are essentially building a private self-hosted cloud that seriously rivals expensive, off-the-shelf commercial NAS devices, all while drawing only 8 to 12 watts under heavy load.
And finally, Project 5. This is the one that really proves we are living in the future, running local large language models completely offline using Ollama. Now, for this specific project, that 8GB Pi 5 is absolutely essential, because those massive LLM weights have to be held directly in the system's RAM. 4 gigs simply won't give you enough headroom. But by running Ollama, you can host incredibly powerful models, like Meta's Llama 3.2, entirely locally. It generates text at a highly usable 8 to 15 tokens per second. And if you add a simple Docker container running Open Web UI, you suddenly get a slick ChatGPT-style browser interface for your home network. You get a highly capable AI assistant that works entirely offline, guaranteeing 100% data privacy, and it's running on a computer the size of a deck of cards.
I absolutely love this quote from the community over at raspberry.tips. They noted that, quote, "Local AI with Ollama on the Pi 5 is the most exciting project of 2026. And you know what? It's completely true. It impressively demonstrates the staggering, almost unbelievable amount of compute power we now have available to us at our fingertips. It completely bridges the gap between basic hobbyist tinkering and bleeding-edge compute capabilities."
But here is the surprise fact that really brings this entire explainer together. You don't actually have to sit down and choose just one of these projects. That's the beauty of it. By using Docker Compose to manage all your containers declaratively, a single 8GB Raspberry Pi 5 has the massive compute headroom to run Pi-hole, Home Assistant, your MQTT broker, your Open Media Vault NAS, and Ollama, all at the exact same time. The AI model only really consumes heavy CPU cycles when you actively prompt it with a question, which leaves plenty of background resources for your smart home routines and your DNS routing to operate seamlessly. It is, without a doubt, the ultimate home lab stack.
So we've comprehensively covered the hardware, we've broken down the architecture, and we've laid out the deployments. From that ultra-efficient 02W silently blocking ads in the background, all the way up to the PCI-enabled Pi 5 serving as your own private cloud and local AI brain. The tools are cheaper, they are faster, and they are vastly more capable than ever before. So the only question left for you is, which of these 5 projects are you going to deploy on your home network first? Grab a board, open up your terminal, and start flashing a drive.